but it's been pretty spread out. I just decided we just got to do a quick review. I was going to think about avoiding it, but we got to do it. Okay, so problems like this, absolute value stuff, right? Let's talk about how we solve absolute value equations and inequalities. So here we've got an absolute value equation. What are we going to do first? What's our strategy? What do we always do first with absolute value stuff? Subtract 4 and? Good, and the whole point of that is to do what? Isolate the absolute value. Good, so we want to isolate this part, right? We're going to isolate the absolute value part. So we're going to, as you said, we're going to subtract 4 from everything. That's going to give us -3 times the absolute value expression equals -12. And then you said divide by -3. That's correct. So we end up with the isolated absolute value. Come on. Is equal to what? +4? Okay. So now think what this means. Here's where I think people have trouble. Colton, you need to be this way, eyes riveted up here, buddy. Right? This is something you need to know about. You do, yeah. So if we have the absolute value of something is equal to a number, right? Think what that means. And I think a lot of times people just, they just, if they don't immediately think of it, they just give up on what we do here. But you can power through this. Just reason through this. Here's how you can remember. We can't mess with anything inside the absolute values, right? We have to get rid of the absolute values before we can do any more algebra. But if whatever's inside there, right, is equal to 4, then think what that stuff could equal in there. Whatever's inside the absolute value could equal either what or what? 4 or -4, right? Because when I take the absolute value, I'm going to get 4 in both cases, right? So here's where we have to make the jump from absolute value stuff to regular equations that we can solve. Because we can't go any further as long as those darn absolute value bars are there, right? So next step, whatever's inside is either going to equal +4 or it's going to equal -4, right? So it's 2x minus 4. Now those are regular equations that we can solve. In both cases, it's easy. We just add 4 and divide by 2, right? You could all tell me that. So if I add 4, I get 2x equals 8. So x equals 4. Or if I add 4 here, I get 2x equals 0. So x equals 0, right? Those are my two answers. Okay? So what about inequalities? Okay, with inequalities, same deal. We're just going to isolate the absolute value, just like before. So first step, got to isolate that, right? So we'll divide each side through by -3. Agreed? Okay, but what's the deal when we're working with inequalities and we divide both sides by a negative? What do we have to do? Got to flip the sign. Good. So this has to get turned around, and then over here that stuff cancels. We get just absolute value is less than or equal to, what's that going to be, +92. Okay? Right? Now what? That's supposed to be an X there. Now what? We got to make our trade, right? We can't go any further. We got to get rid of the absolute values. Okay, good, good. So here's where we know. Now think, how do you know which one it is, right? It's either going to be what's inside is greater than -92 and less than 92, right? Where it's going to be pinched in between those values, or it's going to be whatever's inside is less than negative 92 or greater than positive 92. But which one? It's easy to think about. Ignore what's in there, right? Whatever's in there, if it has to have number values that are going to be less than 92 after I take the absolute value, think about the kinds of numbers that would work. Would positive 1,000,000 work? No, right? Would negative 1,000,000 work? No. It would? Because when I take the absolute value, it's going to make it positive, right? So really large positive and negative values don't work. The whole point of this kind of a thing is it's going to contain it between, it's going to contain it between relatively small positive and small negative numbers. It has to be small. It can't be huge, right? So it's going to be pinched in between those values, the boundary values, right? So this is one where we'd end up making the trade. Whatever's inside has to be pinched between the negative value and the positive value outside, right? So we end up with something like that, right? And we know how to deal with that. That's two inequalities in one, right? It's a compound inequality. We just treat all three parts of that equally, right? When we want to isolate x. What are the two steps in order to get the x by itself? Add 44 everywhere and divide by 4. Okay, we can do that. So in the middle, we just get a 4x. Over here, we get a 136. Over here, we get a negative 48. Right? Now what? Divide by 4. So we end up finally, our x in the middle, that's what we want. We get a negative 12 and we get a positive 36. No, it's not 36. What is that? 30, no, we'll say it again. No. 34. 34, there we go. So there's our answer, right? X has got to be pinched between negative 12 and positive 34. Okay? Okay, another one. Same kind of deal, same strategy. We got to isolate the absolute value, right, as always. So first thing we'll do, subtract 8 and divide by 3, right? So if I subtract 8 everywhere, that's going to give me a 132 on the other side, divide by 3, right? So we get our absolute value isolated. And that's going to give us 44. Okay. Now what? Okay. We can't go any further. We got to get rid of the absolute values. So we got to make a trade. Now think about this one. What kinds of numbers could this 2x minus 20 be? It could be 1,000, right? Yep. Could be negative 1,000. But it couldn't be like 10 or negative 10, right? Everybody see that? It's got to be, it needs to be big. The numbers need to be big and positive or big and negative, right? So this is the one where we're going to pick only the extreme values, numbers that are bigger than a positive value or less than the negative value. So we make the trade. Whatever's inside either has to be greater than positive 44, big and positive, or whatever's inside has to be less than negative 44. It's got to be really negative, big and negative. Two steps, you get x by itself in both cases. Add 20 and then divide by 2. So we get 2x is greater than 64, so x is greater than 32. Add 20 here, I get 2x is less than negative 24 divided by 2, x is less than negative 12, right? So there's my two values, okay? All right, what about this stuff? Okay, no big deal. This is real simple. This is the simple kind of algebra. This is not solving, this is just rewriting, right? All we're doing is simplifying. We're just going to use PEMDAS. When we convert something to general form, think what general form means. We could also call that standard form. And that's usually what we call it, standard form. That's just ax squared plus bx plus c form, right? Yeah. That's simplified form. That just means follow PEMDAS. So we're just going to simplify it. Yeah, what are the steps we could follow? Parentheses. There's only one set of parentheses there. Inside the parentheses, x minus 3. Can we combine those? No. So that one we skip, right? Okay, exponents. Yeah. Yeah, we got an exponent, right? So here's our exponent. X minus 3 is what is being squared. So we've got to take care of that first, right? So let's think about that. X minus 3 squared. What does it mean to square something?
2 times the same thing.
Okay, multiply it by itself, right? So one way you could do this is you could just write out x minus 3 times x minus 3 and then distribute and add like terms, right? Okay, but what it's not equal to, remember the mistake that people tend to make with this, and don't make this mistake, it's not, we know that x minus 3 squared is not equal to x squared minus 3 squared, right? Okay, that's not true. That doesn't work. You can't just distribute the exponent. Okay. So this is the long way of doing it. Do you remember the shortcut, though? If you don't, it's not the end of the world, but it's a great shortcut. Okay, remember that if we're taking something, a binomial, and we'll do more with this next unit. Next unit, we're going to talk about binomials and how do we expand them out and how do we factor them and do things. And so we'll hit this real hard. God, dying over here. We'll talk about this in more detail next unit. But for now, if you remember the trick, it's useful, right? If we have something, here's our trick. I'll remind you. If we have a plus b squared, remember the pattern? A squared plus 2ab plus b squared, right? So we're always going to do the first thing squared plus 2 times the product of both plus the second thing squared. So wouldn't we just get x squared plus 2 times x times negative 3? What's that? 2 times x times negative 3. Negative 6x, right? Plus negative 3 squared is 9, right? So that's, the shortcut is good. I mean, it really saves you time. So the first step is just to get rid of the x minus 3 squared. So that takes us down to negative, and then the x minus 3 squared we're going to replace with x squared minus 6x plus 9 plus 7, right? Notice I have to keep that in parentheses, though, because it's being multiplied out front by that negative 1, right? So it's got to stay in parentheses. What's next? Down. Okay, we got to multiply. In this case, we're multiplying the negative 1, so we're distributing. So we end up with negative x squared plus 6x minus 9. Plus 7, and then last, odd like terms. Okay, no big deal. Okay, so we finally end up with negative x squared plus 6x, and negative 9 plus 7 is minus 2. So there's our answer, right? Okay. Choosing graph. So let's quickly review how we do this stuff. So this is in what form? This is unit 3, right? We hammered this stuff hard in unit 3. So this should be a really easy question for everybody, right? What form is that in? Vertex form, right? So that's the form f of x equals a times x minus h squared plus k, right? So what are the values of a, h, and k? A is 6, h is -4, k is -1. So remember what that tells me, right? H and k are the coordinates of the vertex. So that tells us that the vertex is at -4, -1. Okay, so -4, -1 puts us right there, doesn't it? Okay. What about A? Okay, so A tells us what? Vertical dilation factor, right? So that's telling us, what do we multiply the normal, if we look at the shape of the parent graph, what do we multiply the normal y values by? So normally, we would, for our parent graph, we would go over 1 and up 1, right? We'd go over 2 and up 4, right? And then we get the reflected points on the other side, and that gives us the shape of our parent graph. Right? That's the shape of y equals x squared, right? Everybody agree? Okay, that's not what we got though. This one has been stretched by a factor of 6. So we're going to multiply all of those values by 6. So for example, instead of going over 1 and up 1, 1 times 6 equals 6. So we're going to go up 1, 2, 3, 4, 5, 6 to get that point. Instead of going over 2 and up 4, we're going to go over 2 and up 24. That's off the chart, right? So we don't even need that one. But we got this guy, and then we got its reflection right there, okay, around the vertex. There's my vertex. So there's the line of symmetry, and all I got to do then is just connect. And there's my parabola, right? That's the one we want. Okay, it's going to go through that point and that point and that point. That's really all we need. Okay? That allows us to pick the right one. Questions? Okay, so that's review from Unit 3.
Wait.
Yep.
I'm still confused on this. How did you get like where they reflect? How did you get that?
Okay, because of the axis of symmetry, right? We know that the parabolas have that reflective symmetry about the vertical line that goes through the vertex, right? And so this line right here, that goes through the vertex, you know, that's what we call the axis of symmetry. So anytime we get a point on the right side of that, we can just immediately reflect it over and get a free point on the left, or vice versa, right? So this point right here, we know that if we went over 1 and up 6, we'll just go back 1 and up 6, get another point. Okay? Yeah. Okay? Other questions? Okay? So here's another one. Now this is a new one. This is a Unit 4 problem, but I just want to show you that it's essentially a Unit 3 problem. Right? This is all we have to do is just find the values of A, H, and K and do it exactly like we did in Unit 3, because those are the important pieces of information to come up with a graph. If we know the location of the vertex and we know the vertical dilation factor, we can always easily make the graph, right? Okay, so what form is this in to start with? Standard form, right? So this time we're going from f of x equals ax squared plus bx plus c. We want to turn that into vertex form, right? Okay? But we don't really have to go through the whole process of converting it. All we have to do is just figure out what values are we going to plug in for A and H and K. We don't even really have to write it down that way. All we need to know are just what are the values of A and H and K, and then we can make the graph, right? If we knew that stuff, think about the last example. All we needed to make the graph was that information, right? Once I had that information, it was easy, right? Same thing here. Well, what's the value of A? That's given to us, 5, right? So we know A equals 5, there it is, right? H and K, we don't get directly, but if we have something in standard form, what's the trick for finding H? What's the little formula we use? Negative B over 2A. So what do we get if we plug that stuff in? So what's B? Say it again. Negative 20. What's C? Okay. So negative B over 2A is just going to equal positive 20 over 2 times 5 is 10. So it's 2, right? H is 2. So K is just the y coordinate. How do we, if we have a function, how do we find any y coordinate? Plug it in. Plug in the x value and find the y value. So K is just going to be f of 2. Well, what is that? So the way we can calculate that is every place we have an x, just put a set of parentheses so we can plug in a number. So we get 5 times x squared minus 20 times x plus 15. Well, if we plug in x equals 2, what's that give us? 2 squared is 4 times 5 is 20, right? Negative 20 times 2 is minus 40 plus 15. So what is that? Negative 20 plus 15 is negative 5. So we get H is 2, K is negative 5, A is 5. That's all we need, right? We just write that stuff down. That's all we need to graph the thing, right? So the vertex is going to be at 2, negative 5, so over 2, down 5. Right? And if A is 5, then instead of going over 1 and up 1, we're going to go over 1 and up 2. 5. We're going to multiply by 5, right? We're stretching it so it's 5 times taller. So whatever we used to do, we're going to make it 5 times bigger. So instead of being there, we're going to be 1, 2, 3, 4, 5. We're going to be there, right? So we get that point. We can reflect it over the axis to there. And then once again, we've just got a tall, skinny function. Yeah. Okay, no biggie? Right? No biggie. What about this one? What form is this in? Factored form. Good. So A times x minus p times x minus q, where p and q are just the x-intercepts, right? So what are those values? We know what A is. We don't even really care, but what's A? 2. What's P? No, negative 1, right? Because we're subtracting, right? So P is negative 1. What's Q? Which one? Positive, right? Because it's x minus q, and this is x minus 5. So q must be 5, right? Okay, so if we know that p is negative 1 and q is 5, those are my x-intercepts, and so there they are, right? There and there. Okay, there's 2 points on the graph. All we need to do now is find the vertex, and we're set. Well, what's the x-coordinate of the vertex going to be? 2 is correct. How do you know? Yes. It's a middle value, right? So you know that it has to lie on this, has to lie halfway in between. So there's the axis of symmetry, right? And if you're not sure, if it's hard to see on there, what if it doesn't fall in a convenient place? All you do is average the two x values of the x-intercepts, right? So we know that h has to just equal p plus q over 2. We're averaging p and q. So that would be -1 plus 5 over 2 is 4 over 2 is 2, right? So we know h is 2. How do we find k if we have h? Always? We want to find k and we have h. We want to find the y value. Plug it in. So k equals f of 2, which is equal to what? 2 times x plus 2. Sorry, but I did that wrong. Never mind. Fix that. X plus 1 times x minus 5. But x is 2, right? So we're plugging in 2 there and there. Right? And we just end up with 2 times 3 times -3. So what is that? -9 times 2 is -18. So then we know that if we summarize all that stuff, we know h and k are 2, -18. And then we got these other 2 points, and so that's all we need. Now this graph doesn't work. It's not big enough, right? But the choices you'll get on Moodle will be. So that point really needs to be like way down there. It's going to be, way down here somewhere at the point 2, -18. And then we'll just graph just a parabola from there. Right? So that's it. Okay? Yep. No biggie? Got it? Okay, last couple problems here, solving systems. So here's a linear system. Okay, how do we solve a linear system when it's written in standard form like this? We're going to use substitution or elimination. I mean, you could this time, but it's really set up to do elimination, isn't it?
And then
Why?
You can only use substitution if it's easy to isolate a variable, right? So usually what that means for us is if there's an x or a y with no coefficients, then we could get it by itself pretty easily. But otherwise, it's not worth it.
Yeah.
Right? So this time, if we're going to use elimination, just think ahead a little bit. Which variable are we going to eliminate?
probably
The y's. We're going to multiply. How are we going to eliminate y's? Multiply
divided by 2.
bottom by 2, right? So the top one we'll just leave alone. Bottom one we'll multiply 2 through both sides. And that's going to give us, top stays the same, -12x plus 6y equals -72. If I distribute a 2 all the way through both parts, what do I get?
Negative 6x minus 6y.
Okay, and then 0 times 2 is 0. Okay, good. So if we add all this stuff up then, look what happens. The y's cancel. We get -18x equals -72, right? So if we divide each side through by 18, by -18, we get x equals +4, right? And where do we go with that? Plug it into whichever the easiest equation is, right? How about the bottom one out of our first equation? So if we plug it in right there for x, we're going to get -3 times 4 minus 3 times y equals 0. Then we just solve for y, right? So that gives us -12 minus 3y equals 0. What are the 2 steps in order to get y by itself? At 12, then divide by -3. Good. We add 12. You told me divide by -3. so we get y equals -4. So if we combine that stuff, then we know the x value, we know the y value. So there's our answer. Okay? All right. What about this one? This time, I can just use elimination without doing any multiplication, right? If I add these things up, look what happens. On this side, the x's cancel and the y's cancel, so I just get 0. Over here, the -22 and the 22 give me 0. How do I interpret that? If I get a true equation with no x's and y's, what's that mean? No. Infinitely many. How often is 0 equal to 0? Always. So we get infinite solutions. Now, what if, so this one's going to be infinitely many. What if we got an answer instead that was like 0 equals 10? It's never true, so we get no solutions, right? Okay, last one. Linear quadratic system, okay? So this is one where we'd want to use substitution, isn't it, right? This time we've got, it's easy to isolate a variable. In fact, we've got two choices. The variable's already isolated, so you can really take your pick. Let's just go ahead and pick, not that this is the only way, you could pick the other one, but let's pick the top one. So let's put our box around the top one because that's our substitution equation. So then where we have a y in the bottom, we're going to replace that with an x squared, right? So what do we get when we do that? So we get x squared equals -6x minus 8. Okay, here's where you guys are getting to the point that math's getting more complicated, right? You got to stop and think about this stuff before you rush in. This is just going to be a quadratic equation. It's got x squareds in it. Right? So think what we did in all of Unit 2. We spent a ton of time on this stuff. What form did we always want to put a quadratic equation into? Set it all equal to what? 0. Right? Put it in standard form. Get it all equal to 0. So we're going to put it in the form ax squared plus bx plus c equals 0. Right? That's our goal. We're going to write the equation in standard form. So we're going to add 6x and add 8. We get x squared plus 6x plus 8 equals 0. Okay, that's what we wanted, right? Now think what we're doing, right? Now we can pick the easiest strategy. We can't isolate x because I have two different kinds of x's there. I could use the quadratic formula, but can I make it easier? Can I find magic numbers? What do they have to multiply to? Multiply to 8, add to, what would those be? Multiply to 8, there you go, 4 and 2. Okay, so we factored it. Now by the zero product property, what are the solutions going to be, right? Remember that when I get this broken into a product of factors, the only way I can multiply to 0 is when I multiply by 0, right? So what are the possible solutions then? So by zero product property, either x equals what? -4, or x equals -2, right? Those are the values that work. Okay, so are we done? No, not exactly, right? Because we need ordered pairs. We need values of x and y. So we have to take both of those possibilities and see where they take us. So if x equals -4, we'll go back to our substitution equation and find y. What's y equal to? 4 squared is 16, so one solution is 4/16. Okay, what if we pick x equals 2? Then y equals 2 squared, which is 4. So we get these two solutions are the ones we get, right? Those are, what would those look like in terms of the graph? If I had Desmos available, I don't on this test, but on the second test I do. if I were to graph those two, I'd get a parabola and a line, and at what points would they cross? Those two. Okay, we good? Yeah, track's gonna be fun today. All right, have at it. Get questions answered, test tomorrow.